Now we are going to use some properties of square roots. So here is a property, and it says if I have the square root of a times b, I can actually break that into its separate square roots and say that's the square root of a times the square root of b. Notice this is multiplication. This does not hold true for addition. So if I have the square root of a plus b, that is not the same thing as saying the square root of a plus the square root of b. So if I take a look at the square root of 9 times the square root of 4, I can break that down and say that's the same thing as saying the square root of 9 times the square root of 4. Well, 9 times 4 gives me 36, and the square root of 36 is 6. But if I looked at it this way, I could also say, hey, square root of 9 is 3, square root of 4 is 2, 3 times 2 is 6. Look, it works. So this example shows that that works. We can use this property to help us simplify. And when we do that, we're going to think about that list of numbers that I just showed you, they're common square roots. So when I think about that list, I'll take a look at something like square root of 20. Now you could stick this in your calculator, and when you do, you're going to get 2 point something, something, something. But we're not looking for a decimal. What we want to do is pull out all the whole number underneath that radical sign that we can. So I'm going to think of that list that I had earlier, and I'm going to say, is there a number on that list that divides into 20? And lo and behold, 4 divides into 20. So I'm going to rewrite the square root of 20 as the square root of 4 times 5. And then I can use my little property that we just learned that says I can break these apart since it's multiplied, and that's the square root of 4 times the square root of 5. And when I do that, I can then say, hey, but the square root of 4 is equal to 2. So I'm changing that square root of 4 to 2, and I still have the square root of 5. I'm not going to change that. Notice we always write the whole number out in front of the radical. So the square root of 75, I'm going to think, if it says simplify, I'm going to think, okay, what on that list divides into 75 nice and evenly? And that would be 25. So I can rewrite 75 as 25 times 3. So this is the square root of 25 times 3, which is equal to square root of 25 times the square root of 3 because of my little formula. But I know the square root of 25 is 5, and the square root of 3 is just going to stay as the square root of 3 because I can't divide it any further. Well, now let's take a look at one like the square root of 12. Well, the square root of 12, hey, that's the same as saying 6 times 2. It's also 4 times 3. Which one would I choose? Well, I'm going to go with this one because the square root of 4 has a nice whole number, and if I finished that out, well, that's the same thing as saying the square root of 4 times the square root of 3, but I know that the square root of 4 is 2, and I'm going to be left with the square root of 3. Well, now let's take a look at one that has variables in it. So this is the square root of 25 times x cubed. Well, that's the same thing as saying the square root of 25 times the square root of x cubed. So the square root of 25, but hey, the square root of x cubed is the same thing as saying x squared times x. So I can break this down into the square root of 25 times the square root of x squared times the square root of x. And I know that the square root of 25 is 5, the square root of x squared is x, and the square root of x is just going to stay as the square root of x. Now here, let's take a look at this with more variables. If I have the square root of x squared, the square root and the x squared cancel each other out, so that just becomes x, and that's because x times x equals x squared. So if I looked at the square root of 49x squared, well, the square root of 49 is 7, and the square root of x squared is x, so that would give me 7x. Square root of 16x squared y squared, well, the square root of 16 is 4, the square root of x squared is x, the square root of y squared would be y. If I looked at the cube root of 125a cubed, well, the cube root of 125 is 5, because 5 times 5 times 5 gives me 125. And the cube root of a cubed is a, because a times a gives me a cubed. Now let's say I want to look at the square root of x to the 6th. Well, I can rewrite this as saying I want to know what the square root is. Well, that's the same as saying x cubed squared, because 3 times 2 gives me 6. And so the square root of x cubed squared would just be x cubed. Now there's a nice little trick that we can do, and the little trick says this. So the little trick says if I have an a value here for my index, and I take the square root of x, that's the same thing as saying x to the 1 over a power. So the cube root of 8 is the same as saying 8 to the 1/3 power, which would be 2. But if I had something like this, the square root of x to the 4th, that's the same as saying x to the 4 divided by 2, which is equal to x squared. Or if I had x to the 12th, that's the same thing as the cube root of x to the 12th. So that's the same thing as saying x to the 12th power divided by 3, which gives me x to the 4th. So that's a little trick that you can do.